Let's do a quick review of scientific notation. And we're doing this quick review because scientific notation is used in physics all the time. We're going to assume that you've seen scientific notation in other classes, and so we're just going to cover a few basics here. Basis for scientific notation is that it's a way to represent really large and really small numbers. So here's a couple of examples, and again, a positive exponent, that's going to be for your large numbers. A negative exponent, that's going to be for your small numbers. Remember that negative is small, positive ones are big. And that exponent represents how far you'd have to move the decimal point to get it into the format and the place where you need. And so for large numbers, that's going to be stretching it over 1, 2, 3, 4, 5, 6, 7 positions. For your small number here, that's going to be shifting it the other direction, 1, 2, 3, 4. So if you're given a regular number and you need to put it into scientific notation, you can count out where the decimal places are. If you've got a number in scientific notation and you want to know how to represent it, you're adding the zeros either before the numbers or after the numbers so that your decimal place would shift the correct amounts. One of the reasons why we really care about scientific notation in physics is because it's so much easier for computers and calculators to work in scientific notation than it is to work with all those extra zeros. So let's talk about a few different ways you can see it. We've already looked at sort of the standard format where you've got your number times 10 to the exponent 7. But depending on how we're writing things out, we may not want to represent it that way. So for example, in physics, x is sometimes used as a variable. And so rather than getting confused with the variable x, we can use a different sign for the multiplication. If you're having to type things out in emails, it's really hard to put those superscript up there for the raised to the power of. So you often see the caret notation. So this lets you know that you can have 10 as an exponent of 7. Now, calculators can work with this, but the calculator format that's used most often is actually this E notation, where this capital E represents the exponent. So rather than having to worry about times 10 to the, you can have just your capital E. And you may also see it with the plus or the minus in there to explicitly write out, is this a positive exponent or is this a negative exponent? Let's take a look now at how this would look on an actual calculator. So let's take a look at scientific notation on a real calculator here. So here I've got a Casio, and if I do my standard typical notation like you might see written out, 2.53 times 10 caret to tell me that's to the 7th power, it gives me my notation. But what I want to show you here is the easier way to do this. 2.53, use your exponent button. On a Casio, that's EXP. 7, and that's going to give you your number in scientific notation. This is much easier to work with in your equations if you're using that E button that we talked about calculators and computers really liking. And that wraps up our basic review of scientific notation. Make sure you're using it in your physics course.